hybrid workshop like this where we have a group online and then we also have folks here in the audience. So thank you for, if you're back and you joined us 2 weeks ago, for coming back and for helping us navigate this process. And if it's your first time to join us for one of these, thank you for taking part in this with us. And as we continue to experiment and learn how to do these well, to make a program that is valuable and beneficial to people in person, but also to extend this and offer this to people online as well. So thank you for showing up today. I do want to remind you, you got this yellow form if you came in person. If you're online, you will be receiving this link later at the end of the session to do this online. But if you're here in person, you can fill this out. It really helps us figure out the best way to improve our workshops. It helps us learn what is relevant to you, and it also helps us as we make a case for the impact that we're having. You know, the fact that we're able to open up and have a facility like this, provide you lunch at no cost to you, doesn't come at no cost. It comes from the support of people who make our funding available to us. And so having the information and the impact to report back to them is very, very critical to being able to continue to do the work that we get to do with OSU Extension. Folks online, we will have someone moderating our chat board. So I encourage you, if you have questions, if you have things that you are wanting addressed, to just type in the chat board. You are muted and will not be able to unmute yourself. So you will have to use the chat board if you want to talk with others or if you want to dialogue with us here. We will be taking note of any questions that come through, and as we have an opportunity towards the end, we'll take some questions from you folks joining us online. That being said, I am going to go ahead and share my screen and start our presentation today. Okay. So I find it pretty funny. We've been dealing with really, really hot and dry times, and in comparison to the last 3 or 4 years, really, we were in a dry spell. Lots of the parts of the state were in drought. And then the day we scheduled to talk about irrigation efficiency and irrigation technology, right? The weather has a sense of humor and decides to just downpour on us. But if you've lived in Oklahoma for any period of time, you know that our weather patterns are extremely inconsistent, and we can have stretches of time where we have almost no rainfall, very, very dry periods, and then we can have flash floods and quick bursts of, thank you, Danny, bursts of rain that is just overwhelming. And so while we are here to talk about irrigation efficiency in terms of how we can reduce the overall amount of water that we need in our landscapes, thinking about weather patterns and the natural rainfall that we have is a big part of how we manage water efficiently in our landscapes. And so we'll highlight some of those things today. If you've seen me talk on this subject before, you've probably seen this slide, but I always like to remind people why we care about talking about this. So if you were around Oklahoma City in the year 1980, the metropolitan population would have been around 600,000 for the entire metroplex. Today we stand, we're waiting on 2020 census data to give us actual numbers today, but we're standing somewhere around 1.4 million people here in the Oklahoma City metro. So we've more than doubled our population since 1980, and a lot of new homes have been built. And if you think back to from 1980 to now, I think you'd agree with me that sprinkler systems and landscapes back in the 1980s may have been more of a luxury than they are today. New homes are built oftentimes with sprinkler systems, just a part of the build process, and they're not a luxury amenity that you have to add on later for a lot of new build homes. And so because of that, we have a major increase that's occurred over that period of time, that 40-year period of time, in terms of the volume of water that is needed to supply the needs of our metropolitan area. In general, the 12-month average, the yearly average of water usage for Oklahomans, about 40% of all household water use is going to be outdoors. That's going to be watering landscapes, other things that you would do with water outdoors, filling pools, things of that nature. And about the other 60% would be used indoors. However, during summer months, it kind of flip-flops. So here in Oklahoma City, it gets above 50%, and in some places, I know Edmond has told me that they get above 60% of household water usage in some areas going outdoors. And the EPA has done a lot of research over the years, and a lot of other universities have done research in terms of water usage in landscapes. We know that about 50% of all water that's used outdoors is actually lost due to inefficiencies. It's lost due to wind, evaporation, runoff onto driveways and things like that. So you think about 50% of all of that water, let's say 50% of all water during the summer months is going and being used outdoors, and 50% of that is completely wasted. You can estimate then that about 25% of all household water usage during the summer months is just wasted water usage. So take your water bill and cut it in a fourth, and that's money that could be back in your pocket if you think about ways to really improve efficiency. And really more than that, if you think about really maximizing efficiency. And so we're going to talk about a lot of those things today. Smart Irrigation Month. Anybody heard of the term Smart Irrigation Month? Good, good. So we have some new folks to this. Smart Irrigation Month is the month of July, and it's a national campaign that started several years ago through the National Irrigation Association. It's actually an international organization, folks from all over the world that work in irrigation industry, both in agriculture and in landscape irrigation, come together, and kind of the body of the organization that provides continuing education and resources and networking is the Irrigation Association. And they have designated July as Smart Irrigation Month. And so actually many communities across the country, even here in Oklahoma, the city of Oklahoma City, city of Edmond, city of Tulsa, in years have designated through proclamations from the city leaders have made proclamations designating July as Smart Irrigation Month. Why July? Well, just about anywhere in the U.S., specifically if we look at Oklahoma, though, July is going to be our hottest and it's going to be our driest time of the year historically. Certainly there are going to be exceptions to that. You look at today, we had a pretty good rainfall, but if you look at historic trends, historic averages, July is going to have some of the least amount of rainfall, and it's going to have some of our hottest temperatures. I promise you, you look ahead to next week and you look at the forecast, there's some 105, 106 degree day temperatures. When we have temperatures that hot, our evaporative losses, that means the water that we're losing from the landscape, goes way up. The stress on our plants, the amount of water that they need to function normally goes up. And so July is designated as Smart Irrigation Month because that's when we typically need the most supplemental irrigation to maintain landscapes and to maintain crops in agriculture. And so there are a bunch of different ways that you can implement water saving strategies, water conservation practices within the landscape. Some of those are more management type practices, the way you think about how you design your landscape, the way that you implement management, things like mowing, and if you mulch your landscape beds or not. And we talked about a lot of those things at our last workshop on June 26th, the landscape design for water conservation. We won't talk about much of those things today. Today, I'm going to focus on some of the technology. So this is assuming that you are already thinking about some of the other things, the other practices like utilizing well-adapted plants, mulching your soil so that you have less evaporative loss. Those basic horticulture practices, basic gardening practices are things that we can certainly discuss. If you have questions about, you can bring those up, but I'm not going to focus on those today because we've covered those in other workshops and in other series. And so I'm going to really hone in on trying to highlight some of the tools, the resources, and some of the technologies that can kind of send you over the edge in terms of really maximizing efficiency. And for those of you here in the audience today, you'll see some of the props that I have up here. I've got an irrigation board that has some of the controllers that you might find. I've got some other props that we'll talk about as we go on through. Has anyone ever seen this label, this water sense label on products before? I promise you, if you walk into Home Depot or you walk into Lowe's or even really any store, Tractor Supply, Walmart, any garden center here locally, if you pay attention to water using products, you'll see this label. If you've ever purchased a washer or a dryer or a refrigerator, you've seen that Energy Star label that is put on those appliances. That is a label that the EPA created that designates that product has gone through some testing, and it designates it as a product that is more efficient than a comparable conventional product. So it provides a level of increased efficiency in terms of your electric bill. The Energy Star label does. The Water Sense label focuses on water use, and they slap this label on indoor fixtures like faucets in the house, but they put this on toilets. If you purchase a toilet now, you'll probably see this on toilets, but it's also on outdoor water using products like irrigation controllers, irrigation heads, drip irrigation, things of that nature. And so if you look for this, we'll explain a little bit more kind of what it means, but this label is basically referring to the fact that this product has the EPA's backing as being a more efficient product than some alternatives. This label below there is called the Smart Water Application Technology certification. It is actually a label that has been put out, or a certification that's put out by the Irrigation Association. And this is a little bit more intensive. They actually take products through a rigorous testing and they publish their results and kind of give them like a B, C, D, E, F type of ranking. And so rather than just saying this product can provide some efficiency for you, the SWAT products actually get kind of like a letter grade. And so they're ranked against each other a little bit more. And so you get a little bit better understanding of exactly how efficient that product is with that Smart Water Application Technology label. So I explained this a little bit. The Water Sense label is identifying products that perform a little bit more efficiently. Typically, that threshold is at least 20% more efficient than the conventional baseline product that it would be compared against. And so it's products that provide measurable water saving results just simply by using them. A good example in indoor would be toilets. Anything in the late 80s through early 90s, toilets had as much as like 5-gallon flushes. So you would flush a toilet and you would send 5 gallons down every time. Now they've fine-tuned toilets to where you can get the same flushing capabilities and flushing power, and you're using maybe 1 gallon of water every time you do that. So the same thing with these outdoor fixtures. They are fine-tuning these products so that you can get the same or better results using less water to do it. Again, the SWAT is a little bit more comprehensive than the EPA's testing. It actually gives a letter grade. You can go to irrigation.org/SWAT and you can look at some of the products that they've tested and that they've sent through their battery of tests, I guess would be a way to put it. They test things like rain sensors, soil moisture sensors, irrigation controllers, irrigation heads. All of those things are in the SWAT testing. And so they give some great recommendations in terms of these products on that website. They also have a smartphone-friendly irrigation controller list. We'll talk more about smartphone controllers later today, but if you want to find a complete list of controllers that are available to purchase, they have a great list of some of the controllers that are out there, and they really get detailed in terms of how they perform, where they're getting their weather data, how much they cost. They compare them against one another. So jumping into the meat of today, we're going to talk about both drip and automatic or overhead irrigation practices. Okay, we're going to talk about technologies that apply to both. For my in-person audience, show of hands, how many people have automatic sprinkler systems in their landscape? Okay, so maybe half, or around half. How many are irrigating exclusively with water hoses or some sort of soaker hoses, drip irrigation? Okay, the other half, basically. So we're all needing to use water in our landscapes or we wouldn't be here today, but it looks like about 50% have automatic irrigation and the other 50% are relying on some sort of alternative. When you look at irrigation types, there are a lot of products out there and a lot of ways to get water to your plants, but you can boil them down to three main areas. You've got the overhead sprays. Those are going to be used in automatic irrigation systems, and they pop up when they're pressurized and the water is turned on, and they spray a fixed pattern. They don't move, they just spray a fixed pattern. And they're most commonly used in small turf areas and in landscape beds. Rotors are going to be, they're called rotors because they rotate, they move. And so those are the larger ones that you see spraying much further distances, and they're actually moving. The pattern is actually rotating across the landscape. Those are going to be used in large turf areas most commonly. That's really the exclusive intent for rotors, is to cover large turf areas. And then drip irrigation is often used in vegetable gardens, in ornamental flower beds, really awkward shaped beds that are hard to evenly apply water with overhead irrigation. And when you think about efficiency of these products, the overhead spray irrigation is going to be the least efficient. This is going to be more efficient than, let's say, the impact sprinklers that you screw onto the garden hose, things of that nature, but it's going to be the least efficient. Rotors are in the middle, and then drip is the most efficient. And the reason for that is the rate that they put out water. So a spray head is going to put out water at somewhere around 1 to 1.5 inches for every 1 hour that you run that spray head. A rotor is going to be about 3/4 or 0.75 inches for every 1 hour. And drip irrigation doesn't even put out water fast enough to calculate in inches per hour. They actually calculate it in gallons per hour. And so you're going to have much more efficiency as you get down into drip irrigation, because you have less wind loss, you have slower application rates, which means you get more infiltration rather than runoff. You have the water applied right at the soil surface, so you get less evaporative loss, less wind loss, things of that nature. Drip irrigation has a lot of applications, but like I said, it's mostly used for irregular shaped beds, ornamental flower beds, raised bed gardens, potted plants, things of that nature. There are advantages and disadvantages to drip, so don't hear me say that drip is always the best option. While it is more efficient, it's not always the most practical option, and so you really do have to think about the setting and the situation that you're going to be using drip in. Some of the advantages of drip irrigation are that it uses water more efficiently, it provides a precision application, and the reason that it can do that is typically it is pressure compensated throughout the line, which means you're going to get the same flow. Soaker hoses do not do this, so I'm specifically talking about drip tubing, not soaker hoses. With soaker hoses, you'll find that you turn them on and you get maybe a lot of water at the beginning, and then you get less water at the end of that line because they don't evenly distribute water. Whereas drip irrigation, you know you're going to get the same volume of water out of this section of the drip tubing as you do 10 or 20 or 30 feet down the line. And so that's important. Drip irrigation is applying water right where you need it, which is right at the base of plants, so you get fewer weeds. Some of the disadvantages are that it can easily be damaged. A lot of times if you have moles or gophers or other pests in the yard, they realize that there's water flowing through those lines, and they'll get thirsty and they'll chew right through it to get a drink. And so there can be some ongoing maintenance and just seasonal tasks associated with upkeeping drip irrigation. Anybody ever installed a drip irrigation system at home? Sort of, kind of? You tried? Okay. It can be really, really intimidating for people. I think it seems scary. I promise you that it's not as hard as you may think it is. And there are a lot of helpful resources. We have resources at OSU, both printed and video resources you can find on YouTube. And then you do a quick YouTube search and you can find a plethora of people trying to help you put together your irrigation system. But in general, a properly installed drip irrigation system is going to look something like this. You have your point of connection to the water source. So this could be the spigot on the side of the house. It could be a horsehead or frost-free spigot out in the yard somewhere, or it could be any supply of water that you can tap into. Once you have that water supply, it is best practice to put a backflow preventer right after that water supply. These can be purchased for they're little thread-on things. You can find them at any box store, any garden center that sells irrigation equipment. You can find a little backflow preventer. It doesn't allow water that passes through to go back into your water supply. It's a safety thing. Pressure regulators are also very important. If you don't have a pressure regulator on your drip system and you have somewhat high pressure at your water source, you'll find that your lines will blow. You'll have splits in the pipe, in the tubing, and things of that nature, because drip irrigation is designed to operate at very low pressures, usually around 15, 20, no more than 25 or 30 psi at most, but usually around 15 or 20 psi, pounds per square inch of pressure. And so the water at a spigot is probably going to be somewhere around 50 or 60 psi. And so you want that pressure regulator to reduce pressure. Filters are not always necessary, but they're important, especially if you're watering off of wells or you have hard water. It can really gum up your lines, and so having a filter is important. And then you get right into your drip tubing. And we'll get into this more in just a minute, but drip tubing is where a lot of people go wrong. They think they can just go and purchase anything off the shelf, drip tubing wise. But there are a lot of subtleties you have to think about when you're purchasing drip tubing. One, do you want your emitters spaced 18 inches apart or 12 inches apart or 24 inches apart? The drip tubing all comes in usually in preset, or you have to poke the holes yourself. Do you want flow rates from your tubing that put out water at half a gallon per hour, or at 1 gallon per hour, or at 2 gallons per hour? And so we'll talk about some of those things and how you make the decision of what tubing that you would use. For drip tubing, you base the type of tubing that you use based on the soil conditions that you have. If you have a heavy clay soil, water is going to tend to hit the soil, and it's not going to be able to infiltrate very quickly. It's going to move horizontally across your site. You're not going to get very rapid infiltration. So you need a slower rate of water. And so you'll typically go with something around that 0.4 or half a gallon per hour. It'll be one of the lower rates. You'll have longer run times that you'll have to operate your drip irrigation as a result. You may have to double the run time. You get the same amount of water, it's just applied more slowly over time, so it's more effectively getting into the soil rather than needing to run off. As you go up to a sandy soil, we know sandy soils infiltrate very, very quickly. So sandy soils, water is going to tend to just shoot straight through vertically. And so we need a faster infiltration rate so that we can get more water into that soil. This is kind of what it would look like if you have your drip on the ground. With a heavy soil, it's going to tend to balloon out like you see on the far left of this picture, and then the sandier soils, it's going to tend to be very narrow. So in a lot of conditions where you have very sandy soil, you tend to have to actually put more drip tubing and space it closer together. You might be able to get by in a heavier clay soil with longer run times and less tubing, versus more tubing and shorter run times in a sandy soil. Drip irrigation retrofit. So if you have these awkward beds you're currently operating with pop-up sprays or things of that nature, I see this a lot right at the front entrance of people's homes. Builders, for whatever reason, think it's a great idea to create some weird triangle-shaped bed right on each side of the entrance to your house. They put these heads in there really close together, and you get all this spray that goes off onto your sidewalk, and it's just a mess. As plants mature over time in those areas, it becomes very, very difficult to irrigate with your traditional spray heads. And so there are some resources available that allow you to very easily and cost effectively convert those beds over to drip irrigation. We'll be giving one of those away later today. The one we'll be giving away will allow you to convert the spray head to micro irrigation, so you can run it to a potted plant or something of that nature. But these are available anywhere you can buy garden products, and they easily allow you to convert a spray head by putting a new gut down inside of it, a new body down inside of the spray head. You're able to convert it over to drip irrigation. Very simple. So you see here on this slide, the right-hand side of the slide, this little cap that you see right there, that is often referred to as a Xeri cap. Xeri as in like xeriscape, X-E-R-I, which stands for dry. So when you have, let's say you have a bed here and you have 4 or 6 heads in this bed, you don't need to put a drip line on every single one of those. You might pick one spray head at one end of the bed, run tubing, your drip tubing off of it and coil it through the bed one direction, and then pick another head at another end of the bed and coil your tubing through it from the other direction. You can take these caps and screw onto the top of the other heads, and they tie those heads off so that they don't allow water to escape. You can use these also when your landscape changes. How often do we buy a home, then we start putting in, we put a shed here, we put a new flower bed there, and then we have a mess because we have rotors in one corner that are now spraying into, onto the shed, or they're spraying into a tree, or, the landscape changes and we don't change the way we irrigate with it. These caps can be used to cap off things of that nature where you don't want irrigation anymore. And so they're a very simple way to do that. Again, this is what that would look like. I have a Rainbird example here. There are many different irrigation product manufacturers. They all make various products that can do these things for you. So Rainbird just happens to make a really readily available and easy to use kit that can retrofit a sprinkler head. So you can look for those in stores, and you can do them. You can retrofit them into drip tubing, like you see here at the bottom of this picture, or you can retrofit them into using other attachments. You can retrofit them into little spaghetti, or what we call micro irrigation tubing, that you would run to a potted plant. And that's what this would look like. So it's often referred to as a spaghetti tubing or micro tubing, and you run it into a potted plant or right under the base of a plant, and you can add different emitters and give water off of your main drip line that way. Now, if you're thinking about a vegetable garden on a larger scale, oftentimes this is what you'll see. You'll hear people talk about T-tape or drip tape, trickle tape. Anybody who's doing like farmers market vegetable production, certainly probably using irrigation on this scale, this type of drip irrigation, but even small backyard in-ground vegetable gardens, this is a good fit. It's inexpensive, it's very mobile, easy to replace, and so it's this flat plastic tubing that serves the same function as the more rigid circular plastic tubing that you think of when you see the drip irrigation like you see here. But this tubing is flat, and it again comes in different spacings, different flow rates from the tubing, different features and functions based on what you need, based on your soil conditions, things of that nature. And so in a vegetable garden setting, it's the same process that I described earlier, where you have a water source. In this case, for instance, like the way I irrigate at my house in my vegetable garden is I stretch a long garden hose from a spigot near my house, and then I have my whole hookup. So I have a backflow preventer, a pressure regulator, a filter, and then my drip tubing. And then every row of vegetables, I just splice in a row of irrigation tubing. And so that's kind of the way that works. These are some examples of what that could look like in an in-ground setting if you were doing either raised beds or in-ground vegetable production. Okay, so again, feel free. We've got some online folks that may have questions that we'll get to towards the end. But in audience folks, if there's something that can wait till the end, we'll take some questions at the end. But if you have any pressing questions through this, feel free to stop me if it's pertinent and relevant to what we're talking about right now. I'd be glad to focus in or talk more specifically about something if you need. One thing I really wanted to highlight today, because I think a lot of us use we use hoses, we use faucet timers, and a lot of them are such a pain to use. They depend on batteries, and the batteries go out or they stop working, or maybe we just depend on our old brain and we turn on the hose and then we expect to remember. You know, we'll set a notification on our phone, or we'll set an alarm and we'll expect to remember to go turn that hose off. Well, I can tell you, before I started using hose timers, especially before I started using more sophisticated hose timers, I would frequently forget that I had a hose running somewhere, and I'd come back and it might have been 24 hours that a hose had been running, or and that happened to me all the time. And I know I'm not alone in that. I know people do that all the time, and it can be a real nuisance. And so I still water. I don't have a sprinkler system on my property in my home, and so I do a lot of watering with hoses or drip irrigation. And what I have started to utilize more is what are called smart faucet timers. They're basically the same thing as the irrigation controllers that you would use for a automatic sprinkler system for your landscape, but they go on to your spigot and to your drip tubing. And these are just some examples here. So down here at the bottom left, we have this Melnor one. It is a 4 zone, and it works just like a normal timer would for a hose sprinkler system, except for it is Wi-Fi enabled, so you control it from your smartphone wherever you're at. You can see when it last watered. You can see when it's scheduled to water again next. You can turn it on and off in real time from your phone. It also will receive rainfall and weather data to make recommendations and amendments to your watering schedule. So today, I think the weather reporters got it wrong, because I did not see this in any forecast I saw today. But right, but so it takes that forecast and that weather information to make decisions, but it also will use real-time information. So every 5 minutes or so, these things can get data and get information to amend. So it may not have stopped it before. If the forecast didn't recommend shutting it off, it may not have stopped it before, but certainly within a few minutes of that rainfall, it would have decided to kick it off. So these are some technologies you can use. There are other brands like this Orbit Beehive that I really like. The reason I like the Orbit Beehive is you can integrate a lot of different products. They have the outdoor and indoor timers. We actually use their outdoor timer to control our irrigation system here on this property. Yes, sir. Question.
I don't know if anybody else has this problem, but I probably waste more water from the faucet to the hose. That little thing never is unsure, and water just splashes everywhere.
Yeah.
Does anybody make a faucet or a hose that doesn't leak?
The question from for our people online from the audience was that so much water is wasted from the connection points of hoses, and how do you address that? I would say it's an issue that is hard to solve. I'd say the way I try to address that is I use quick connects almost everywhere, and so I can easily disconnect, and you have a tight connection on each hose end, and they just quickly joint together. Quick connects help that. I also make sure that every year I go through and I replace all of the little O-rings, the rings within the hose, to get a better seal. I also use, on joints that I'm not going to be moving a lot, I use the white tape that you would use for like a irrigation or plumber's tape. I use that to seal those threaded pieces, and that really helps. So usually doing those things will significantly minimize it. I still have areas where there's a little bit of water leak here and there, and I think it's not an easy thing to solve. So I think it's a problem that we all deal with. But those are some of the strategies that I use solve that problem. It's a good question. Another thing that you can use is flow meters. Flow meters sound a little bit complicated or scary, but they're really nothing more than as water goes through, they are spinning and they are calculating the volume of water that's passing through. They have simple flow meters like this one here, which you would just attach onto the end of a garden hose, or you can put it onto the base of a garden sprinkler head or a handheld watering wand, and it will just tell you how much water has passed through in gallons. And so for the curious, if you want to know how much you're watering, it's kind of helpful. You can sit there and hold the water on a plant and say, oh, I put a gallon down, or I put 2 gallons down. That's kind of helpful. For other settings, you can use things like this. This one's a Melnor brand, but they make lots of different brands. And I was talking with some folks in Shawnee yesterday. Master Gardener group out there is having some trouble with some of their timers that were going rogue. I don't know if the batteries were dying or what. And they were not smart timers, but dumb timers. And they were basically, they had programmed a schedule in, and it was supposed to be watering at this day and that day, and it was watering at random times that it shouldn't have been. And so one of the things that I thought of as a possible, I use these for this purpose, but as a possible kind of fail-safe or a check against that is you can attach these down from your timer, and you can actually set, just like you would a timer, except for this sets it on a gallon usage. You can set a maximum threshold for how many gallons you want that to meter out before it shuts off. And so you can use these. This one goes up to 1,200 gallons. They make some that go larger than that, but it goes as small as 200 gallons and as high as 1,200. So let's say you were watering and you knew you were going to be away, and for whatever reason you wanted the peace of mind to know that you weren't going to allow it to go more than 1,000 gallons or 500 gallons or whatever. You could use these for those types of situations. Or just to kind of, you know, if you're just curious, you want to know about how much water you're using in terms of a gallon's number, it's helpful to get an idea on that. So. This slide, we won't spend a lot of time here today because we're not really talking about the horticulture management side of things, but when you think about water management in any plant situation, you hear this term evapotranspiration. And evapotranspiration is a combination of 2 words, evaporation and transpiration. And so evaporation, of course, is the water that's lost from the sun's radiation. It dries it up, takes it up. And then transpiration is what the plant takes up through its root system and then uses and transpires or sweats out. And so the combination of those 2 things give us a total water use value for a plant. We can know based on temperature and humidity and wind and all of those things, we can get an idea of how much water is going to be lost through the environment. And we can also know based on research data and things that we know about specific plants, we can also know how much water that specific plant needs to use based on given conditions. And so that gives us an idea of how much water plants are going to need. And so you can use something technical like ET to make water management decisions, or you can use general principles like hydrozoning, which is thinking more about plants, less about their specific month-over-month water needs, and more about, in general, does this grass, ornamental grass, need more or less water than this shrub or this annual flower, and trying to group plants accordingly to their water needs. And we talked a lot about that in our last workshop, but I just wanted to highlight that this all really plays together. So Bermudagrass, this slide here shows the month-to-month water needs for Bermudagrass. Many of you have probably seen this before, but the first column there past the month where it says average Bermudagrass ET, that is the 30-year, let's see, 1998 to 2018 data from right here in Oklahoma County. They aggregated all that data, and the average water need to maintain Bermudagrass at an aesthetic quality was 4.7 inches of water for the month. Now that's before any rainfall. So after you subtract the amount of rainfall we normally would get here in central Oklahoma, which is 2.9 inches, then we have a 1.8 deficit. It means that for the month of July, to maintain our Bermudagrass lawns, we would need to add about 1.8 inches of additional irrigation to the lawn to maintain a truly green, happy, healthy lawn that we all expect. This does not mean you have to do that in order for your lawn to survive. It will certainly survive. It has great drought tolerant characteristics, but this is more for aesthetic qualities. So when you're making a decision about how much to water, what does that mean when somebody says water your lawn for an inch a week? Well, there's some simple ways. You all walk, if you came in the audience today, you're going to walk away with a little rain gauge, which will help you. You can set this out somewhere. It's nice to have more than one of these, but you can set this out somewhere representative of what your irrigation schedule is going to be, and you can see how long of a run time it takes you to get to 1 inch. And typically 1 inch of 1 inch of rainfall a week is the standard recommendation for Bermudagrass. That's before rainfall, though, so you do have to think about how much rainfall you've had and back off on your irrigation as a result. However, this slide here, I think illustrates just how much we can easily be overwatering without realizing it. So let's say that we need before rainfall, we need 5 inches of water for the month of July. It's more like 4.7, remember, so it's a little, 5 is generous, but we're expecting that there's going to be some loss to runoff and evaporation and things of that nature. If we use rotors, so we have a rotor zone, and we water every other day, which based on our odd even watering schedule that we're all under here in the Oklahoma City metro, we'd be putting out 6 inches for the month. So we'd have a overage of irrigation of about an inch, 1.3 inches. If we watered with sprays, because remember I told you earlier that they use more water, about in some cases, depending on the product, as much as twice as much, you would be putting out 12 inches a month if you watered every other day for 30 minutes. So understanding the products that you're using, so the zone by zone, it's going to be different in terms of output rates. Understanding your soil types, understanding all of these things really help you make informed watering decisions. But in general, you can estimate that you're going to have twice as much water usage for a general spray head, a conventional spray head, as you would a rotor. And so if you're watering a rotor zone the same amount of time as you are a spray zone, you're likely either underwatering on the rotor zone or you're way over watering on the spray zone. And so thinking about how you manage your run times and how you manage your settings on your sprinkler system are really important. This is a feature I like to point out to people. Most controllers have what's called a seasonal adjust feature. And you can see it indicated here by this arrow on the screen at this, this little part of the controller right here. The seasonal adjust feature basically takes into account what we just talked about with those slides where I showed you month by month, the Bermudagrass water needs are going to be different. So we'll go back to that. The water needs of Bermudagrass in even May and June are actually, we have a surplus. If you factor in rainfall, we have a surplus. So July and August are really the 2 months of the year where some additional irrigation is going to be perhaps very, very important, if not critical, to maintain your lawn. And so when you think about that, rather than having one set schedule that you operate the whole season where you say, I'm going to water every other day for this period of time, and then sure, if it rains like it did today, I'll run out and turn it off or whatever. This allows you to go in and assume that July and August are your 100% schedule. That's when you're going to need the most water. So let's say our 100% schedule is every other day for 20 minutes. Then you can taper it so that month over month, the amount of time that schedule waters is reduced as a percent. And so that's called a seasonal adjust. And you can certainly look through YouTube videos that will walk you through how to set this up on your controller. And I'd be happy to, if you need help with that, to help you navigate that as well if you have a controller that can do this. Also, I want to say in just a little bit, I'll be getting into some of the smart controllers, which will make this irrelevant. But if you don't have a smart controller, this is a way to kind of think a little bit more efficiently about how you use water. Okay, you heard me talk about high pressure earlier, or just pressure in general. The average, based on my experience with Oklahoma City and Edmond, I would say is somewhere around 50 to 60 PSI, which is the average delivered water pressure to most spigots around the house where you would have irrigation water, or at most sprinkler systems. And the optimum pressure for a spray head is going to be 30 PSI, and for rotors is 45 PSI. When I say optimum, that means that all of the, what I told you about a spray head using 1 inch or 1.5 inches for every 1 hour of runtime is based on these pressure parameters. As pressure increases, that flow rate actually proportionately increases as well. And so you can significantly see a rise in the amount of water you're using from a spray head over the same period of time based on how much pressure you have at that spray head. So to give you an example of what I'm talking about, if you see irrigation in a landscape and it looks real misty and foggy, I don't know if this is a technical term, but it's a way I like to describe it. I call it back billowing, where you have like wind just blowing and it creates these little puffy clouds that roll away like mist at a theme park when it's hot in the summertime. That mist is just blowing everywhere and it's real cloudy and foggy. That's high pressure. That's a visual indication of high pressure. And what you see here on the right is you see flow rate from 0 to 6 in terms of gallons per minute. And then you see pressure on the bottom from 20 to 60. So at around 25 or so PSI, you have just under 3 gallons per minute coming out of that spray head. As your pressure increases up closer to 60, you get closer to 6 gallons, or you almost double the amount of water coming out of that spray head. And so you're using more water. Now, why is that a bad thing? Well, 1, you're using more water, but 2, you're using more water and getting poorer results. Who likes to spend more money and get less, right? We're all about a deal. I am. I would rather spend my money efficiently. And so if you look at this example here, this is a testing that was done. Running a sprinkler system at its designed PSI, 30 PSI, delivers 3.3 gallons per minute at every single sprinkler head. And it gives you pretty uniform coverage. The blue line there you see on the left was the intended arc of coverage for that spray head. The same spray head, when you up the PSI to 50 PSI, because of how volatilized those water droplets become when you increase the pressure, they become mist and they just blow off into the wind. Look at how significantly reduced that coverage was. So you're reducing the effectiveness of that irrigation head to do what you designed it to do. You're getting less water where you want it, and you're spending more water to achieve those results. Question here from the audience. If you have a well, there are different ways of doing that. If you're anywhere that you're tapping into the water, they have little pressure gauges that you can put on any water stream, and it will kind of give you an indication of your pressure. I can show you those after today. I don't think I have any pictures of that here today, but there are ways to gauge pressure, and I can give you some advice on that. Some of the technology, if you think that this is an issue with your sprinkler system, there are different ways to correct this. But one of the simple ways is just every time you replace a head, think about replacing it with what's called a pressure regulating head. So they're a little bit more expensive than just walking into a hardware store or a garden center and buying a traditional sprinkler head, but they're going to regulate the pressure coming out of that head to the right pressure so that you get this result here on the left every time you irrigate versus this result on the right. You're using less water, getting more efficient coverage, and so it definitely pays off for you over time. It doesn't matter what brand you use, what brand of sprinkler head. They all make pressure regulating spray heads and rotors, and that's a very simple way to do it. There are other ways to address pressure, of course. You can use pressure regulating valves that will regulate pressure across the entire system. That becomes more costly and usually involves having to hire an irrigation contractor, but a homeowner, a gardener can easily replace a sprinkler head on their own and do it very cost effectively. And so rather than spending a bunch of money to do this all at once, I like to recommend to people at least every time you have to replace a sprinkler head or you're going to be doing any maintenance, think about replacing. And over time, you can very quickly replace a lot of these. They're probably going to be around $5 a piece. So let's say you have 10 sprinkler heads on a given zone, you're going to spend 50 or 60 bucks to transfer that zone to this. And so you can do the math and kind of figure out, okay, what would my payback be if I did it? But here's an example. Based on that example that we just showed you, 50 PSI uses 4.8 gallons per minute from every single sprinkler head. If you reduce it to 30 PSI using a pressure regulating spray head, you're reducing the amount of water you're using by 1.5 gallons for every minute of runtime from every single head. And so that is equivalent to, if you had a 20-minute runtime every single day, an odd even 20 minutes every other day, about 450 gallons a month per sprinkler head that you would save by reducing pressure. 450 gallons a month per sprinkler head per zone. So that's 26 showers a month per sprinkler head that you'd be saving potentially. And this slide just basically shows that the higher the water rate is, the faster your payback is going to be. The more expensive water is, the higher your water pressure is, the more quickly you're going to pay yourself back for spending a little bit of money to make these changes. And based on some case studies that I've seen done in the past here in Oklahoma City Metro, the typical payback for doing this is easily within a year or 2 years for sure. And that was with water rates of 2015. Water rates continue to grow and to go up. I know City of Edmond and other communities around are experiencing rate increases. And so these technologies are really starting to become a much quicker payback in terms of how they yield results for your bottom line in terms of your water bill and saving money month over month. Question? Well, right. So you're saying there's more pressure, it's shooting further. Yeah, I think that to a certain degree that's true. You get to a point where that water particle is volatile or so small that it's by the time it would be getting to where you want it to go, it's drifted off in the wind or it's evaporating. And so yeah, with a hose, certainly you can maneuver your finger and control the arc, and you can turn the hose up to allow more pressure to flow through a garden hose. That gives you a little bit further output. But I think it's a little bit different situation from a sprinkler head because you could extrapolate it out. If you put the pressure up so high through that garden hose, at a certain point it would achieve the same result. But it's a different scale. So I don't know if that makes sense, but. Yeah, well, they are working towards, the question is about nozzles and efficiency for those that are in-home audience. And so the question was, do they make nozzles that can take higher pressure? And there are some nozzles now that are called matched preset nozzles. So they actually allow you to put on a spray head and match the lower flow rate and precipitation rate of a rotor. But there are some products that can withstand a little bit higher pressure threshold, but most sprinkler heads are not going to be able to withstand, that's a big pressure differential from 30 psi to 60, 70, 80. I've seen pressures of well over 100 psi in home landscapes, and that can just be very, very damaging. So I think there are some products that do give you a little bit higher pressure threshold, but at a certain point, the higher the pressure, the more pressure, the less effective in terms of efficiency your results are going to be. A good question. There are nozzles now as well called high efficiency nozzles, and you see that here on this slide on the screen. Most brands make high efficiency nozzles. These two happen to be Rainbird nozzles. So on the on the left, you see a normal nozzle. It's a variable arc nozzle, so you can actually control just by twisting the nozzle. You can control the arc that it flows, but it's a normal nozzle. And so you see the pattern. See how the water particles are much smaller, they're finer. The high efficiency nozzles shoot out water that has much larger droplet sizes. So they're less likely to be blown away in the wind. They're gonna be heavier, so they're gonna land on target more frequently. And some research that I've seen basically says that you can achieve 30 or 40% efficiency just by using a new nozzle that's a high efficiency nozzle. So there are certainly lots of different products and lots of different options out there that can really help you achieve efficiency. And over time, Danny, to answer your question, I think like anything, you saw that at the beginning of this presentation, I talked about the Water Smart products, the Water Sense label. At a certain point, we begin to engineer this efficiency into products anyway, rather than it being something that is an up buy. It's just a standard. And I think over time, that's where we're headed with these things. And so we continue to push every ounce of efficiency out of these products to where it's standard. And so the toilets is the case in point. Nobody's manufacturing toilets anymore that have 5 or 6 gallon flushes. They just aren't. And part of that is because there's some regulations that prohibit that, but also, that's just standard practice in the industry now, is to improve efficiency and improve standards with products. So.
There are a lot of cities back 50 years ago that had that pressure, that's why they ate or sprayed it like that, or it's like Edmond out of the ordinary.
In terms of, so the question from the audience is having to do with city delivered pressures and what would be normal. It's going to depend on how many water towers there are, how many people are drawing on the city's water supply. Back many years ago, most sprinkler systems were made from brass or copper, which could tolerate higher pressure thresholds, and so there's a lot of issues at play. Certainly, the city supply has to do with some of it. The products themselves and the materials they're made of have to do with some of it. So I don't know if I can directly answer that question, but yeah. Thank you for that question. Okay, as we get into the last little bit of this presentation here, into some of the some interesting stuff, I think we're going to talk a little bit about irrigation controllers. And irrigation controllers are essentially the brain cell of an irrigation system. If you're using a hose-in timer, that's a controller for your drip system. If you're using an automatic sprinkler system, then this controller would be the same function. It's sending an electrical signal to allow that valve to open and close at a certain time that you've set for it to do that. And this is kind of what the anatomy of a controller looks like. So it's plugged into the wall here, and you've got the controller, and you can mash some buttons, and it's got a wire that goes out to a master valve, and then also to each of the individual zone valves. And so every time you push a button that says open zone 1 to allow water to flow through, that electrical signal comes from the controller to that solenoid, opens the valve, and that's how it works. And so it's not terribly complicated. It's It's not much more complicated really even than basic lighting on and off. And so standard controllers that we've had for generations are great in terms of allowing us to have some sort of automation to how we manage our water and our landscape. But they aren't always terribly efficient. A lot of times, my experience has been with homeowners, they find that their sprinkler controller on the wall in the garage is sometimes confusing, hard to operate. You mash a button and you think you're doing one thing and you're not doing that thing. And so there's just a lot of frustration, a lot of intimidation that comes along with some of the older controllers. And to be honest, they're not much more sophisticated than, you know, my mom's old kitchen timer that she would twist and it would tick really loudly and then it would ding after 30 minutes or whatever. That's essentially what they're doing. You twist the dial, set the time, it dings off. But it doesn't give you much nuance in terms of how you manage your irrigation based on site-specific things, based on weather, based on rainfall, based on plant needs. It leaves all of that up to you as the homeowner to have to figure out how to manage that. And so smart irrigation controllers, a lot of them, I have a few of them here today on our board to display, and I will also, for those of you at home, be going through some of them that we have here today to show off. But essentially they're like the smart thermostats. If you're familiar with like the Nest or things of that nature, they can make modifications in real time, like we described to those hose-in timers. They can modify your schedule based on the weather, based on custom information that they know about the zone. So you can go in and actually say, okay, this zone 1 is my front lawn and it's really compacted, hard clay soil. Zone 2, there's a slope. Zone 3, there's some shade. And you can input information like that into a lot of these controllers, and it uses that information to really give some custom watering recommendations specific to your site and to your landscape. And so the results of that are that you get much more efficiency. Again, controller runtimes are often self-adjusting. You can get remote access to your irrigation controller right from your smartphone. You can turn on and off your sprinkler system. So if you happen to be away from home or traveling or have multiple properties or whatever, you can have a little bit more management control over how your sprinkler system is operating. There's been a lot of research over the past 15 years in this area specifically, both water utilities across the country and then also universities. And they all have shown that there's significant opportunity for water savings, achieving better or the same results with our landscapes, but using less water. And when you think about smart sprinkler systems, there's really or smart controllers rather, there are really two there's a fork in the road and kind of two directions you can go. There's some of the real hardcore people say, well, if I'm relying on weather information from a local weather station or somewhere, you know, some weather aggregate agency that's out of state or whatever, they may say I'm projected to get rain and we get 3 inches of rain 2 miles from my house, but I didn't get rain at all here because it all blew just to the north or just to the south of me. And we have that happen a lot here where we'll have pockets that get a lot of rain, but then just down the road a few miles away we may have no rain. And so sometimes people are very big advocates of what's called on-site sensors. You can actually use rain-freeze sensors and soil moisture sensors and things like that and wire them into existing controllers to modify your schedule based on real information from your property. It's going to know, is there rainfall right now on your property? What's the soil moisture content right now on your property? Or you can use the controllers that I was talking about where you can take in weather data and it automates a lot of that for you. If you use on-site sensors, there are different products available. Again, ET sensors, rain sensors, and soil sensors are kind of the three main categories. ET sensors are going to be focused on evapotranspiration, trying to make sure they're delivering exactly the amount of water that a given plant category would need. Rain-freeze sensors are going to be moderating whether it's raining or whether you're getting close to freezing temperatures. And soil sensors are kind of modifying your schedule based on what they know about how much moisture is in your soil. Typically, most plants can need a little bit of dryback. A healthy soil is going to be 25% oxygen, 25% water, and 50% other materials, organic matter and nutrients. And so a healthy soil has to have a little bit of room, dryback, so that oxygenation is occurring, and then wetting again, so there's water in the soil. And so soil moisture sensors essentially use that principle, letting the soil dry back to a certain point, and before it dries back to the point where the plant is going to be stressed out, it allows irrigation to happen again. So there are lots of controllers that are based on this kind of technology. A lot of the Toro and Rainbird products are based on using actual sensors that you use on site. Sensors can really be great ways to save water. Rain-freeze sensors specifically here, this is how it works. They have wireless ones that you would put on like the gutters or even your house, and then you have a little module or remote module thing that's wired into your controller, and it receives a signal. And typically the rain-freeze sensors, the way they work is you can set a threshold, but usually it's around 1/10 of an inch of rain. If it detects 1/10 of an inch or greater, it will shut off for a period of either 24 or 48 hours. And then also 37 degrees is usually the threshold for the cool temperature. So if we get a temperature swing, let's say in the fall, September, October, sometimes we don't quite get freezing temperatures, but we can have a real quick swing in cool weather. It might shut off your irrigation for that. We see this all over town. You've probably seen me share this picture before. I stole this picture, but I see it every time I drive by. This is May Avenue, and you see it all over town. When it's raining, I'm sure today there were sprinkler systems going off all over town, and just adding mess to the rainfall. And not only is it wasting water, but it actually creates damage to the landscape. Over time, excess rain like this, excess moisture can damage the grass, it can damage the sidewalk and the hardscapes around. This here's another picture from Oklahoma City that I also stole. You can have things like this happen here in Oklahoma, where we get a quick swing in temperature, and we have a freeze that we didn't know was coming. And so again, having some of these products in place save us from having some of these headaches. Yeah, it looks like good uniform coverage. That's a good point. Good uniform coverage of that ice across the lawn. Soil moisture sensors, like I described, typically are looking at a 50% moisture threshold. So they're going to see the soil as a sponge, essentially, and when the soil moisture level is depleted to 50% of the zone that it is measuring, it will allow irrigation to happen again. There's been a lot of research. New Mexico State University, University of Florida, University of Arkansas have all done some research trials on these, and they've shown at least a 50% water saving potential using products like this, because it's specifically giving a tailored dose of moisture to the soil based on what the soil really needs. And so essentially what it's doing is it's allowing the water in the soil to get down just above the point where the plant's going to be stressed. You don't want it to get to what would be called the wilting point, where your plants really start to sag and show significant stress. You want to water just before that if you can. And so it's monitoring that and allowing irrigation to occur right before plants would be stressed. Doing that actually creates stronger and healthier plants. If you're just constantly watering plants when there's no need for it, you create shallow, weaker root systems. You create plants that are less resilient when they do face stress. And so actually watering this way, whether you're doing it with a soil moisture sensor or whether you're doing it with a hose or an automatic sprinkler system, however you're doing it, if you allow some dryback, it really creates stronger plants. And that's why the odd even every other day watering system is not really necessarily the best option in terms of what's best for your landscape or best for you. It's a water management strategy. And so you may be able to get by with twice a week or 3 times a week watering, or even less, depending on what the plants are and how established they are, how much mulch cover you have, how good your soil is, things of that nature. These are some of the soil sensor products that are out there. The Toro Precision Soil Moisture Sensor is a wireless one that you actually just stick out in the ground. You can mow over it. You don't even know it's there. I've had people lose them in their yard before because they hide that well under the turf. They are battery powered, so they have to replace the batteries about every year. Then there are wired ones. This is the Rainbird version. They have wired ones that are buried in the ground near your automatic sprinkler system's zone box, and they monitor moisture. All right, so this is some information on the Wi-Fi based controllers. They allow homeowners to have the remote access, like I talked about. You're using them from your smartphone. I think the thing that has really changed over the last several years is how affordable they've become. I remember back to when Blu-ray players first came out, and they were ridiculously expensive, and now you can practically get them for cheaper than toasters and stuff now, and people are giving them away because they're not going to be around for much longer. And so, you know, the same thing with any technology, as over time they become more accessible. These products are either the same price or just a hair more expensive than any old irrigation controller you would buy off the shelf. You can find some of the smart controllers that only are 4 or 6 zone controllers for as cheap as $20 to $40. As you get bigger and you need more zones to manage, you know, so let's say you have a 10 or 12 or 16 or 20 zone controller that you would need, then of course the expense is going to go up. But for the most part, right around the $50 to $100 mark, you can buy a lot of controllers, the smart controllers. Some of the real Cadillac ones may be closer to $200 or more dollars. The other thing that a lot of people are getting excited about is the fact that, like anything now, they are capable of interfacing with our phones, but also our voice activation. So whether it be Siri or Amazon's Alexa or whatever Google's Echo is, you can integrate those controllers with voice commands so that you could be sitting on your lazy boy watching TV and say, hey, Alexa, turn on the sprinkler system zone 1 and get the mailman wet, or whatever you want to say, and it will do that for you if you set that up. So those are some of the things that are kind of the next wave of technology as it's coming through. I want to highlight a few of the products as we wrap up today that are out there, and I have these physically on display today for anybody afterwards that wants to kind of walk by and see them. The Ratio product was kind of the first to the game. They kind of created this whole industry. They are probably what you would consider the higher end version of a smart controller. Very, very user friendly, works very, very well. Has great ratings, great efficiency, and it's going to be around the $200 mark to as much as $300 if you need a really large landscape controlled by it. It is 100% through the app, so it has no buttons that you touch on the controller itself, which freaks some people out, especially old irrigation contractors that are used to mashing buttons and twisting dials for years. They look at something like this and then they kind of scratch their head. So it's not for everybody, but certainly is a great product. This is what the app interface would look like. You can actually take pictures of individual zones. You can name them zone 1, or you can change the name to front yard, backyard, flower bed, vegetable garden, whatever. And you can set the amount of time with your finger here. You can just roll and increase or decrease the amount of time that you would water, and hit run now to start it. You've got calendars of watering schedules and things of that nature. Like I said, almost all of them allow you to actually preset information. So you can go in and say, okay, my front yard. I'm going to enable the smart watering, and I'm going to give it some information. So you can say, okay, this is a tall fescue, it's clay soil, it gets some shade. I'm using fixed spray heads. I have a slight slope. You can answer some questions. You can even get more advanced and put in more information, and it'll take all of that into account when it's making the management decisions. Orbit Beehive is the one that we have here on our campus that controls our sprinkler systems here at the extension office. You can see we have one of the Orbit Beehives here, the indoor one that is, it controls just a few zones, and then the outdoor one with an enclosed box. They're moving away from the buttons, but they do have models like this one. It's the same controller, but it has all the traditional buttons as well. So you can interface with the app, or you can mash buttons if you need to mash buttons. And so those are kind of the average approximate prices that you would find those for if you went. And again, these are available at almost any store. You can find these at Home Depot, Lowe's, Walmart, Amazon, sometimes Tractor Supplies, and local garden centers will have these as well. This is what the app would look like for this one. It's the one that I use here on my phone to control our sprinkler system. Same thing, you can control the length of time. You can see a calendar of when it last watered, when it's supposed to water next. You can set notifications, so if for some reason something goes wrong or it doesn't water, you get a notification. So really, really helpful. This is the Hunter HydroWise, just another product that's out there. You see it on our board here for your in-person audience. And it is about $150. It is, it's a good product. I don't have tons of experience with it. What I do know is a lot of the Hunter products are moving towards trying to get you to pay for a subscription to get the weather monitoring information. And so the one downside I would say for this is that if you want ongoing real-time weather information delivered to this controller, I think the last time I looked into it, I think that they were trying to get you to pay a subscription for that. So we all have Netflix, we have Hulu, we automate everything, but I don't know that we all need one more subscription that just automatically comes out of our paycheck every month. So I would rather go with another product, but that's just me. The Blossom is another one that's out there. I have really no experience with this, and we do have it on our board on the top right there. It's about $70 and does all of the same things that the other controllers do. There are a lot of controllers out there. So like I said, these are just a few of the ones. If you go back to some of the original slides I showed you, and you go to the irrigation.org website, or if you go to the EPA WaterSense website, there are 3, 4, 5, 6 pages of list of water efficient controllers that are out there. So there are hundreds of different brands, but these are some of the most common, most readily available brands. At the end of the day, using smart irrigation technology can yield you about 20 to 50% water savings, depending on how well you utilize the products. It can help you improve your landscape health and appearance, and it's going to make you a much better water manager as a result. And it's going to lead you to saving money on your water bill and in your landscapes. One caveat, though, that I have to remind people about is you can use technology all day long to really, really make water management more efficient, to help you save water. But at the end of the day, if you have sprinkler systems that are poorly designed, if you have broken heads, you have leaks, you're not able to get control of the hoses and figure out how to stop those leaks and things like that. The technology doesn't solve those issues for you. And so if you have a bad system, you have broken infrastructure, address that before you think about just putting a new controller in. So always start with the low-hanging fruit of just repairing and replacing things that need to be fixed and repaired and replaced. That's the end of my presentation. I'm going to go through a few quick slides. What? Mesonet. The Mesonet, I forgot to mention that. The Oklahoma Mesonet is a great resource for just general information. I use it every day to check on. I find it to be really, really useful for kind of making determinations about watering or looking at the past week or month in terms of how much rainfall we've had or what temperatures have been. It is not a forecasting tool. It's a data aggregation tool. So it's not going to tell. It does have a small on the app. It does have a small, like I've got the Oklahoma radar right now up on it, but it does have a small forecast landing page on the front. You can set your location and it'll take forecasts for you. But it's not like watching the news where you get a forecast in terms of how much rainfall you're going to get or things of that nature. But what it does have is very, very detailed information in terms of how much rainfall we have had in the past hour or 5 hours or month. It takes information every 5 minutes. We have weather stations in every county, and usually the county has multiple weather stations. They aggregate all that information and make it available through the Mesonet system. It's a free resource, and it's actually a resource that is a partnership between University of Oklahoma and Oklahoma State University. So people think that we can't get along as a big brother and little brother in the state of Oklahoma, but we certainly can and do in some cases. And the Mesonet's an example of that. OU and OSU and the National Weather Service work together to make that happen, and it is a really unlike any other weather monitoring system in the world, and it's right here in Oklahoma, and we have access to it as Oklahomans, and we benefit from it. So I encourage you to download that app. It's a free app in the App Store, and really, really great resource. If you're not familiar with our fact sheets website, please go to facts.okstate.edu. You can you can search within this website any topic of interest to you. And if we have an OSU resource on it, it will be generated there. So it's a great place to start if you're thinking of trying to find some information. We have an events calendar that you can also go to. It's calendar.okstate.edu. And you'll see upcoming workshops and events that we're having. You can actually register through them right there through our calendar website. On the left-hand side here, you can actually set search results. So you could search by county, by topic area, and find classes and subjects that are interesting to you. If you aren't using our video and YouTube resources, you need to start right now today because we have a lot of great resources. Oklahoma Gardening is a great place to start. We have, of course, the television show that airs every Saturday at 11 a.m. on PBS and on Sundays at 3:30 p.m. Covers gardening topics. It's the longest running gardening television show in the world, and it's right here in Oklahoma. It's been running continuously since like 1972, I believe. And it is a great resource, and you can actually go into the YouTube page. Don't search in the main search bar above because you'll go back to the YouTube black hole, but if you search here, you can find catalog all sorts of videos on topics of interest. So I searched irrigation technology, and there were quite a few videos that popped up. I forgot to mention, I took the slide out, I guess, but we also have an Oklahoma County YouTube page, and I would ask that if you use YouTube, you go there and you subscribe to our page. We're really, since all of the coronavirus hit, we created the page, and we're putting regular information on there. Weekly, we put new videos on. I would encourage you to go and check out the videos. If you just go to YouTube and you search Oklahoma County OSU Extension, you'll find us. Any questions from the audience or from the chat? Online audience, thank you for sticking with us today. We will be sending an online evaluation to those of you who participated with us online today. And so we thank you again for participating. Our in-person audience, if you need to run, you can run. But if you want to stick around, I'd be happy to chat with you. We're going to be giving away a few prizes for some of the people that stay. And we also need you to fill out those evaluations. Thank you. Question. Question is, does irrigation tubing, drip tubing need to go under the mulch? That's a great question. Yes, you can, or you can do it on top. It doesn't have to. a lot of times for aesthetic reasons, people don't want it on top, so they'll bury it under a small layer of mulch, and that's typically what I would do. You can set it on top though, and that's just fine as well. You are less likely to damage it from digging around in the garden if you know if it's visible. But certainly burying it is very, very common practice. So you can do either. If it's buried, no. Usually what you do is you want to make sure that the emitter is typically placed the emitter side up. So against what you might think, the emitter doesn't need to be on the bottom side. The emitter is going to want to be on the top side. And you're just going to set it on the soil surface and put a small mulch layer over the top of it. So you're not really burying it in the ground. You would just be covering it with a mulch layer. All right, we are going to do a drawing for a couple prizes. So Diana, you tell me who our winners are.
So the first winner is
Wanda? Okay, you get to choose since you're the first winner. Do you want the Melnor flow meter that shuts off at a certain amount of gallons used, or do you want the drip conversion kit to convert a automatic sprinkler head to micro tubing for pots? And this one? Okay. You come up here with me and we'll get a quick picture. All right.
And then the next person is Jean Castro.
Jean? Hey, Jean. This is for you. All right. Thank you all for coming. Feel free to stick around if you want to. We can talk. If you need to get on the road, have a wonderful weekend. Thank you for coming and helping us continue to have programming and meet in person. I'm like all of you, I'm pretty sick of this, but I think it's important that we continue to take precautions and be safe, but learn how to live and continue to do life together. And so thank you for helping us do this.
What kind of gardening workshops or whatever you guys have for us? That's important, and that gives us a lot of information. Thank you. Thank you so much. Appreciate you guys. Oh,